Hello everyone, welcome to my channel. Engineer Eric Patrick here. So today we are going to do this assignment in ANSYS Mechanical APDL. So what is this assignment about? This is a steel cantilever beam. So it's an I-beam cross section. I-beam cross section with these dimensions. So here we have settings, the parameters we have to input in ANSYS APDL in order to model and to do the analysis of this beam, this kind of beam. So without wasting too much time, let's get started. So we will open ANSYS, then we go to preferences, so structural, okay, processor, element type, add add beam to node 188. Okay, we close, then we can close element type, then we open material props, then material models, structural, linear, elastic, isotropic. So here we will input the EX, that is the Young modulus, and the PRSY, that is the Poisson ratio. So let's see the values. So AS we have 2.1, E5, and for the Poisson ratio we have 0.3. So 0.1 E5, E5 and 0.3. So okay, so we can close this one. We open density and let's see our density. We have 7800 E minus 12, 7800 E minus 12, and okay, so that's it. We can close. We close material props. We go to our sections. So we have this is a beam, so we come to beam and we choose common sections because we have an I beam. So in subtype we hit here, then we will choose the I beam. The I beam is right here, I beam. And then now we can input the dimensions of our I beam. So we have W1, W2, and W3. So here the W1 and W2 are the outer edges of our beam. The W3 is also the outer. So let's see here. So here we have outer edges, 30 millimeters and 40 millimeters. So here out, so we have 30, and for W3 we have 40. So T1, T2, and T3 are the thickness of our beam. So let's see the thickness of our beam. The thickness is 5 millimeter, and here it is precise that the height of the web is 30 millimeter. The height of the web is 30 millimeter. So what is the height or height? Yeah, so it depends on, on the English we will use, height or height. So what is the height of let me just use height. Okay, yeah, height. Yeah, what is the height of our beam, the web? So here in the middle here, that is what we call web of our T beam section. the middle here. This is what we call web. So when and it is precise that it is 30. So when we remove 5 from the thickness on both sides, down here and up here, 5, we have 10. So 40 minus 10, we will have 30. So it's right. It's right here. So 30, 30, 40, and then T1, T2, T3 is 5 because we have thickness of we have a thickness of our beam. So 5, and 5. So we input all the beam sessions, so we can hit OK. So we can close beam, we can close the session, we come to modeling, create key points in active CS. So no need to put a key point number, no need, because ANSYS will put automatically for us. So let's just input here. For the beginning will be 0, 0 and 0. So this is what we will do in every modeling in ANSYS. So we have to start from the point 0. So 0, 0, 0, then apply. So what is the length of our beam? So we have 1000 millimeter of length. So here in X direction, so 1000, and Y will be 0, C will be 0. So we can put OK. So here, now we can close key points. We come to lines, lines again, straight line. Then we pick from the first one to the second point, and that's okay. So we move this one up, we can hit OK. So we've created the line of the beam. So we can close line, we close line, we close, and we can close create, we can close modeling as well. So now we go to meshing. So we choose mesh tool, and as we have a line here, so we have to choose line here, set. So set, we bring this one up here and then pick all. So what is the size of the meshing? We can input 10. This one is just it depends uh, on the analysis we want to do. We don't really have a precise number of meshing. We can just input any size of meshing we want, from 1 to any number we want. Everything depends on the power of our computer. So the higher the value, the higher the computer will consume power. So let's just input 10, so to avoid our computer to crash. So let's continue 10, and we can leave this one empty, empty, and empty. So okay, so now we have a mesh. We hit mesh tool again, and we can click on mesh here, mesh. We bring this one up, so we pick all, and that's it. We are done with the meshing. So we can close processor. We come to solution and define loads, apply, structural, displacement, and key points. So what are displacements? We want to put our supports. So here in our case, we have, let's see, we have ancastre as support. So ancastre, we bring this one up, so we choose here, because here is the ancastre located, so we hit here. So okay, and ancastre is all DOF, all degree of freedom. So all DOF, and then okay. So here we have the ancastre, and then let's see. Now we will apply our load of 10 kilonewton. So how we can apply this load? We come to force or moment on key points, then we put where the load is located. So we hit here, bring this one up, and then okay. So our load is on the y-axis. So we will choose Fy because it's on the y-axis. If our load was here like this on the x-axis, so we will choose Fx. So now we have our load on the y-axis, so we choose Fy, and we choose right there -10. -10. Why minus? Because the load is applied downward, so we have to put minus. So we can put okay. So here the load is represented here. So that's okay. That's it. Now let's see if our assignment precise any analysis type. So let's see. No analysis type, so we can just run the analysis and see the results. So we can close define loads. If the analysis type was precise before, we can just come to analysis type and then new analysis, and then we choose static, modal, harmonic, transient, spectrum, and so on. So here we are doing a static analysis because it's a beam, so it will be a static analysis. So okay, and now we can solve our beam. So solve current ls, and then okay, we wait for the result. So the result is done, so we can close, and then we can close solution. We come to general post-prod, so plot results, so deform shape, we choose the middle one. Okay, so here we have the deform shape of our beam, because we have a load applied here, so the deform shape is right. So how to see the modeling in a real form, the real form of the beam? So we can come to plot controls, style, size and shape. We can turn on the size and shape of our beam, so we can put apply OK. Let's put OK, and here we have the size and the shape of our beam. So to turn to see the size really well, you just hit on control and right click at the same time, control and right click at the same time, and then you turn off your mouse, and that's it. You turn your mouse, and that's it. Here we have our beam. You see, this is the cross section, I cross section here, like that. So that's it. So So that's it. So to fit on the screen, you just come here, fit view, and then it will fit on the screen. So that's it. We are done with this example, this assignment. So how to save your work after we finish the modeling, how we can save the work. And before that, let's take our beam back to the previous shape. So you just hit plot control again, style, size and shape, and then you turn off. Then okay, so that's it. We just turn off the shape of our beam. So we want to save our work. How we can save the work? You come to file, save as, and then you just remove a star here, and then let's put maybe beam beam analysis. Yeah, beam analysis. That's okay. So here we choose the folder we want to save our work. Let's save it, maybe me, I want to save it in documents. So it depends on you. You can save it anywhere you want, as long as you can, as long as you find it in your computer. So I will save it in documents. So I will just double click on documents, double click. So you double click and then okay. So that's it. We just saved our modeling, our analysis. So this is it for this tutorial. Thank you very much for your attention, and don't forget to like, comment and subscribe for more tutorial like this. Thank you for your attention and see you for the next tutorial.